Today, let's go over a hard question that I just solved by myself. This one is called vertical order traversal of a binary tree, and it's similar to another medium level question, but it has a lot more constraints and requirements to it because you have to sort by different things. So let's get started. So if you observe here, what you want to do is sort by the column and then sort by the particular coordinate itself. So for example, here 6, 5 is supposed to be 2, 0, 2, 0, so we want 5, 6 because they're the same coordinate. And as you can see, we want a list of a matrix of integers. So first, let's do a level order traversal to get all the nodes. So let's append the root, and this is because the root will always have a coordinate of 0, 0. And then let's define dictionaries to keep track of the coordinate and then also the column itself. So, and then if there's a root node, if there's not a root node, then this is not going to be valid. But if there is, then we want to append the actual column value, right, to the dictionary. And we want to do the same thing, but except this time we want to append the coordinate because we're going to want that later to sort by. And so now let's do a level order traversal, iterate through the levels, and then let's do some unpacking here so that we can properly place the values. So what we want to see here is going to be like -1 is corresponding to 9, 0 is corresponding to 315, so on and so forth. And then that's the list we're going to build. And so if the current and if the left child exists, then we're going to append the left child along with, if you look at the picture, x is +1, y is -1. And then we also want to append the coordinate value, right? Because the coordinate value is going to be the one that we sort by the dictionary's keys, right? And so we want to append the actual value and do the same thing for the right as well. But in this case, we also want to keep track of the coordinate in the opposite manner because we're going to want to use that later. So we're going to append the actual coordinate itself. Do the same thing for the right child. Right, it's x +1, y +1. If you look at the picture right here, x +1, y +1. And then y -1 dot append, or y +1 this time, dot append cur.right.value. And then now we want to do the same thing. X +1, y +1. And then now let's print our dictionary. Second D. Okay, I named it wrong. And now we just need to sort by the keys, right? So, well, this is actually not, this is the full coordinate sorting, but this is going to come in handy later because what we're going to do is we want to actually sort by this guy, which is the coordinate value. So let's print that first. Okay, so now you can see 9, 3, 15, 20, and 7. But this isn't the correct answer because if you go by that, you're going to get like wrong answers because 6, 5, you want 5, 6. So now let's sort by the full coordinate values, and that's where the other dictionary comes in handy. But let's first sort the original column dictionary by the columns. So that's going to sort by the keys of the dictionary. And then let's create a results list and iterate over the keys of our dictionary and then append the list itself. Right. Okay. And let's print result to C. That's fine for this, but for another test case, it's not okay. So then we have a lot of work to do here. And now, okay, this is where the hard part comes in, because let's define, this is not going to be the final answer. This is going to be. So now we want to iterate over our list and then create another list that we are going to create another dictionary for, because we're going to map the coordinates back to like 0, 0 is going to be mapped back to the value. Like for example, 2, 0 matches to both 5, 6, 5 and 6, and then we're going to just sort it. So you'll see what I mean. This took me quite a while to write out, so I'm just showing you. So for C and R, so we're iterating over this list, each from left to right. If C is in our dictionary, which is going to be called second D. So if it's key in the dictionary, then let's print C, or let's print the mapping itself. And you can see what we want is a tuple instead. So there's some work we got to do here. We should have, okay, we can just turn it into a tuple. I think that's how I did it. So H equals to tuple, second DC 0, because there's only one coordinate for each value in the tree. And then now we can append the actual value, because we want to map 5 and 6 to the same coordinate. Okay, and then now let's print TD. Cool. So, and then now let's print the current list that we want to compare the values to, because it's not going to be longer than the current list. So this is going to be the same length, it just might be in different order. So now let's create another list, and then so we want to iterate over this dictionary again. And then now we can just extend the sorted version of this, right? Extend sorted TDT. And then we can just append this list, and then I think we just have our answer. Sorted. And it works and passes all test cases. It might not be the most efficient, and it took me quite a while to come up with, but yeah, that's my own solution to it. So I don't know if I'm going to be able to reproduce this in like a week, because this is overly complicated, but I just wanted to show you that it is possible, and I did solve this myself. So thank you for watching, and don't ask me to solve it again in a week, but yeah, so thank you for watching, and stay tuned for more.